Hello everyone, welcome to my channel. Today we'll solve the weekly contest 388 second problem. It's a medium level problem, but it's on like a easy medium level, right? So uh, I hope you would have solved the first problem of this contest, which was a greedy approach, and very similar approach has been like expected from this problem also. So first let's try to understand the question. We have been given array uh, which holds the happiness value, right? And we have to choose uh, k elements from this array. And what happens is after we choose one element, the happiness of all other elements reduces by one, and it does not go negatively. So that is the problem. So for example, here in example one, we have one, two, three. We need to choose two elements. So first say we pick three. After picking three, happiness of two, this one becomes one and this becomes zero. Then we optimally pick that one, so we get four. So that is the answer for that is how we have to make this function work, right? Uh, so this is also a very greedy approach. The greedy approach is to pick the maximum element as early as possible, right? Uh, why we do so? Uh, say we had five elements, for example, one, 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 and nine. Here, say we want to pick three elements, and if we pick this uh, nine first, then what happens is all the elements becomes zero in the first iteration. Next, uh, we need to pick three elements, right? In the next iteration, we could pick any one of this. So 9 plus 0, then there will be three zeros. And again in the next iteration, since it can't go below 0, it will stay at 0. And two zeros will be remaining, right? So this, uh, so the maximum answer we can get is 9. Uh, we could have got same answer if we would have picked this way. Say first we picked 1 and we for that iteration we would have had uh, four zeros, right? Four zeros and the 8. Now if we pick this 8, four zeros should be there. Sorry, just the element here. Yeah, and now if we pick any one of those zeros, yeah. So in this both cases, maximum sum reachable is 9, which makes sense. But uh, say we would have picked instead of this 8, if we would have picked those one of those 0, uh, another one, and this 8 would have become 7. And in the last step, say we pick the 7. See what happens here is uh, this one is giving answer 8 only. When this one gave 9, and this one also gave 9. See, what is the advantage of taking the greatest element first is, anyway, if we are going to take the element smaller than the greatest element in the future, that element won't go beyond 0. See, this one became 0 in the first iteration itself. This one became 0 in the first iteration itself. But it is staying as 0 after all other iterations. But whereas this 9 first became 8, then it became 7. So its value is deprecating. So more optimally, if we took the greatest element first, and if we leave the least other smaller elements, anyway the value deprecating if all are greater than 0 initially is same. But right after they become 0, uh, the zeros won't deprecate below it, but the numbers greater than 0 keep deprecating. So we should greedily take positive elements earlier, preferably the most positive element. So that is the logic behind this. So as you can see, how we can do is we can sort this happiness array in descending order. Now what we'll do is uh, we need k elements, right? So we will directly take the first k elements from this array, and as per constraints, k is always less than n. So in the first iteration, all the elements have same value, and since they are asking the answer as the total sum, will that and the return will be obviously long because of the constraint. Because each element could be as big as 10 power 8, and we can have as much as 2 into 10 power 5 elements. So let's say this as answer. Okay, and this answer will be uh, happiness of I minus I. Why this is, we pick the latest element which is at first index first in the first iteration, and in the second iteration we take the second greatest element. By that time it would have been deprecated by 1, right? So like in the ideal case, like the expected case, first we took 9, 9 came as 9 itself, but after that when we take this one, its value is deprecated by 1. So we subtract happiness of i's value by by the number of iterations we have completed. So initially I was 0. So from the greatest element we don't subtract anything, and from the second element we subtract 1. It goes on like that. Okay, but it shouldn't be, if it's less, it goes less than 0, it would have stayed at 0 itself. So we'll use this one, this max condition. Yeah, this should work. Let's try to run it. Yeah, it works. Let's submit it. Hmm. So the time complexity is n log n, which is well within the constraints of 10 power 5. And the space complexity is big of one only. So if you want to dry run, let's take a complex case which is not in this examples. Say 2, 4, 6, and 3 and 5, right? And say we want to pick k was 3, right? Mm. So what we'll do is in the first iteration we will pick now first we will sort this array. So this array would have become 6, comma 5, comma 4, comma 3, comma 2. Now we will pick 6. The sum was the answer is initially 0 and I is 0. Now 6 is picked, so answer becomes 6. After that, uh, I becomes 1. Now we pick the second element 5 and we do this answer equal to 6 plus max of 0 comma 5 minus I, which is 1. And after that I gets incremented to 2, which is this is equal to 10, right? And after this answer will be incremented to 10 plus max of 0 comma next biggest element is 4 and the reduction value is 2. So it is equal to 12 and I gets incremented to 3 and we stop here. Say if k was 4, let's say k was 5 itself, and now answer is equal to 12 plus max of 3, right? 3 max of 0 comma 3 minus 3 minus 3, which is same as 12. I equal to 4 is equal to 12 plus max of 0 comma 2 minus 4, which is also 12 because max of 0 comma 2 minus 4 is this, which stays as such. I equal to 5 and we stop here. So this is how it works here. I hope you get it. It's very close to the first problem, just the greedy implementation is different. See clearly when in these two cases after 0 it doesn't go beyond 0. That's why we have this max statement, so that it will avoid going below 0 in negative, right? And greedily choosing the greatest element is better. So this is the answer. That's how we solve this question. I hope you understood it. Uh, Try to think why we did this and understand the logic rather seeing the just the code and implementation, so that you could solve another problem in the similar way. If you have not figured out the first question, solve this question and try the first question, so that you get handy with this kind of problems and solve more greedy problems to be good in this kind of questions. Thank you.